All right, guys, your common assessment is going to be on Friday. Okay, it is going to be online. All right, it's very important, guys. You will either be here or you will not be here. Excuse me. You're freshmen. You will be at home. Okay, you only have the specific time reserved for your test. Okay, if you do not log in at a specific time, your test will record as a 0. Okay, you only have a very specific amount of time. So on Friday, it is on your agenda. We'll have very explicit instructions on Friday. So if you forget, just log into Echo and we'll have it step by step on what to do. But you will have to be able to take this by 1:30. Okay, the reserve time is from 1:30 until the next class starts. We will have it already active, and we'll talk about how to access it in a minute as well. Your common assessment review is right here. Guys, you need to finish this. It needs to be 80% or above by Thursday. It is unlimited retries. We're going to talk today how to use Desmos calculator. I know y'all are used to Inspires, but unfortunately, guys, we have some people on campus, some people at home. What the district has determined, in order for it to be fair for everyone, you're going to be using Desmos and not Inspires. Okay, so we're going to talk a little bit more about Desmos today, how we could utilize it for the questions that will be asked on Friday. So what I need you to do, if you haven't already, let's go ahead and click this Common Assessment Review 1. And then we're going to do a split screen. Okay, split screen. If you don't know how to do it, I'm going to walk you through it. Right click here on your link. You're going to open it in a new tab. Once you have it open in a new tab, you just grab the tab up top and drag it away from your internet. Okay, and it'll open up a different window. Once you have that open, okay, you can just play around with the minimize, maximize square. And then I would just minimize both of them and do a side by side. If you have a Windows computer, which I think most of y'all have Chromebooks, you can right click on the toolbar and go side by side. Okay, so I have my Echo here, which would be your test on Thursday. You also have Desmos right beside it. Okay, Desmos is allowed. It will be allowed all throughout your test this year, especially on ACP. Okay, get used to Desmos. All right, here we go. Let's go ahead and start this. Okay, we're going to take a look at a couple of these together on how we can utilize Desmos for these type of questions. We're going to drop down to question number 5 first. Okay, on number 5. Anytime, guys, they want you to evaluate a linear function, such as this one, it's looking for the range of domain. We need to be able to see the graph. Okay, they will give you either a graph, a word problem, or a table. In order to find range of domain, guys, the easiest way is to have a graph in front of you. So if the question does not give you a graph, if it gives you an equation, you're going straight to Desmos and typing it in. This one, luckily, has given us a graph, though. It wants to know which inequality best represents the domain of this function g. Okay, domain, guys. What is domain? What variable? X or Y? X. Very good. If you do not know that, I need you to write this down. Domain is X. Range is Y. That needs to be in your notes. That needs to be in your memory. Okay, on Friday, you will have it for your notes, and it will be out, and you will use it on your test. Okay, it'd be silly to miss it just because you don't know if domain is X or Y. My domain is the X value. My range is the Y value. Okay? Now, I need to be able to identify, and this one, it doesn't want both of them. It just wants the domain. So let me clean this up just a little bit. I'm looking for the domain. We stated that domain is my X value. Before I even start pulling numbers from my graph, guys, if I know domain has to be X, I go down to my answer choice and I cross out which ones?
The ones that don't do
and the ones that have what? Y. Very good. And remember, guys, Y is also known as the function of X, or f of X, or g of X. This is the same thing as Y. Okay, you gotta know that. You gotta know it for algebra. You gotta know it once again when you come back to me in algebra 2. So the function of X is the same thing as Y. So wherever it gives me my Y, I'm gonna cross them out. Okay, do not pick those on accident. Cross them out before you even start.
So, Y
Yes.
is going.
Go ahead,
Okay,
Mr. West.
So Y, Y can be F, G, and Y, right?
Yeah, so y, that's a very good question. Y could be g of x, it could be f of x, it could be y. Okay, just remember, this right here is a variable. Variables can be any letter. They just represent the unknown. Okay, yes, Mr. Kenny.
Am I supposed to do like this? I'm not sure if I'm in the right way.
Okay, so we are looking once again at domain. So I'm going to take a look now at my actual graph. I have already used my testing strategies. I know which two it cannot be. So I need to find my x's. Domain is x. I write it first. How far left does this graph go? Find the endpoints. Remember, the end behavior tells me. What number is it going to? -9. Remember, we're talking about my x. We have to find that endpoint, the end behavior. And we got to go down to the x-axis because we're talking about my x's. I'm going to write it least to greatest. The least number is how far left it goes. It was at -9. How far right is my graph going here? Look at the end behavior, the other end behavior. Where is it?
Negative is 2.
2. Very good. Circle it, guys. Circle it on your x-axis. Okay, a lot of y'all have the annotation on your computers. Use it. So now it goes from -9 to +2. If you always write it least to greatest, like I show you guys, you never have to worry about which way your signs open. Your inequality signs will always open to the right if you write least to greatest. The last thing I need to look at, open or closed circle. Okay? My inequality signs, remember I have 4 of them. Less than, greater than, less than or equal to, greater than or equal to. If there is no bar underneath the sign, are those open or closed circles?
Close.
Talked about it last week.
Open.
Open. These are open circles. If you don't have it in your notes from last week, guys, you should write it down right now. There's a video on it on your agenda from last week. If there is a bar underneath it, the equal to sign. Okay, remember it's half inequality, half equal to. This open or closed circle?
Open.
Well, if the bar is underneath, closed. Okay, closed. This is my last step when writing inequalities for my range and domain. On -9, do I have an open or closed circle?
Open.
So do I need that bar underneath?
No.
No. There is a closed circle at what number?
2. Not.
2 on my x, which means I need that bar underneath the inequality symbol that is with my 2. Okay? Closed circle at 2, that equal to, less than or equal to is with the 2. Open circle at -9. There is no bar underneath it. All right, any questions? What's my answer here?
F.
F. Okay? Remember, boom. The inequality sign equal to has to be with the 2. F is the answer. Any questions? Okay. Let's drop down. We're going to take a look at number 6. So now this is a little different. This is range and domain, but once again, remember, we talked about this. We don't have a graph here, okay? We have to be able to evaluate this without a graph. So I have the total cost in dollars to buy uniforms for the players on a volleyball team can be used. The function C equals 34.95, U plus 625, where U is the number of uniforms bought. If there are at least 8 players, but not more than 12 players on the volleyball team, what is the domain for this function? Okay, here we go.
It's 34.
It's 34? How do you know it's 34?
Because 34, because the domain equals, that's the number that changed.
That's the number that changed? Okay, you're on to something. Let's go ahead and elaborate what he's talking about. So I have 34.95U plus 625. Okay, before I do range domain, before I do anything with the word problem, anytime they give me a linear function, an equation, I have to label it, guys. What does my C represent here? What is this?
Your Y.
It is usually Y, you're right, but what is it relating to my problem?
Your range.
Okay, but my problem, you're right, that is gonna be the range, but what does C represent?
The cost $1,000 for uniform.
The total cost, right? This is my money. Total cost. What does the U represent?
Uniforms.
Uniforms, but where does the uniforms go on? U is the what? Number of uniforms, but let's think about it. What do uniforms go on, guys? What does it usually go on? No, don't think math. Uniforms. You buy a uniform for your team. Who wears a uniform?
Your kids.
Your kids, right? Okay, what we're doing here, guys, this conversation that we're having, you need to have a conversation similar to this when you read a word problem. Put yourself in that position. That's going to help us determine what numbers can fit there. So if I know the U represents uniforms, I know uniforms are going on people. What can a uniform not be? What can this number not be if we're talking about people?
It can be a decimal.
Excellent, Mr. West. Okay, it cannot be a decimal. Okay, it cannot be a fraction. If we're talking about people, it has to be a whole number. Okay, so keep that in mind. Now, what does this problem want? Does it want range or domain? What does it say?
Domain.
Domain. Domain is what variable?
X.
X. In this place, what is it?
U.
U. Very good. So we're looking at uniforms for my domain. Okay, so I know we're talking about uniforms. If there are at least 8 players, but no more than 12 players on the volleyball team, what is the domain? So let's create a table here, guys. My X is U. My Y is C. U represents uniform. C represents cost. What is the minimum amount of players I can have on this team? 8. That's where I'm starting. What's the next number of players I can have? 9. Remember, it cannot be fractions, cannot be decimals. What's the next one?
10.
And then?
11. 12.
Excellent. These are the possible number of players I can keep on my volleyball team, right? Obviously, each player needs a what?
Uniform.
Uniform. Now, this one doesn't ask for range, but remember, we talked about it last week. What controls my range?
Your domain.
The domain. That X controls the Y. So how can I find these numbers right here?
Multiply.
Multiply what?
The number of uniforms times how much they cost, right?
You're absolutely right. Okay? We're going to be doing an example just like this. Our t-shirt group. Okay? This is exactly what y'all were doing. We got to buy robotics t-shirts, right? There's going to be a formula, a function representing how much the shirts are going to cost, plus our shipping cost, right? This is the same thing, guys. They're put in a different type of situation. It's the same concept. So now, it doesn't need it, but let's continue this because they might ask for range on the test Friday. In order to find 8, I know that C is equal to 34 times 9.5 times 8 plus 6.25, right? Well, that's a lot. Check it out. There's an easier way to do it. Let's look at Desmos. On Desmos, we're going to go ahead and type in this equation. Y equals 34.95 X plus 6.25. So there's a graph representing how much our shirts or this volleyball team shirts will cost. I want to figure out how much 8 costs. Well, check this out. I click on the graph, the equation. I'm going to click the circle, and I'm going to hit the table. It converts that equation into a table, guys.
So what did you do again?
So all I did was I had my equation in here. So I'll start from the beginning. Y equals 34.95x plus 6.25. I hit enter. It gives me a graph. Then I need to make sure I have that equation selected. I go to the circle, the wheel, and then I click table. It's going to convert it to a table. Now check this out. It doesn't have the numbers I need. All I have to do, remember, X controls Y. So for my x here, I'm gonna put an 8, and look what it did. It converted that y. I'm gonna put a 9, it's gonna evaluate the function. I'm gonna put a 10, 11, and 12. So for 12 players, how much is it gonna cost? $425.65. You see how we can use Desmos as a tool to help us evaluate functions, right? Now, that's going to come up later. This question, right, we're doing a whole bunch of extra stuff. This question just wanted domain. Guess what? I already have my domain. I know domain is X. The X place was talking about uniforms. I got my uniforms right here. The possible amount of uniforms I could have for this team start at 8 and they end at 12. Now, who can tell me why F is incorrect? Because F has 12 also. Why is that incorrect?
Because it's just showing how many.
Because if
It's just a player.
Okay, it has zeros here. What else, guys? If I put inequalities here, what is technically true here that cannot be true with uniforms?
And I can't zero player in my team and still buy uniforms.
Okay, that's absolutely right. Okay, why else? Can I have 10 and a half
No.
uniforms? No, but technically, in an inequality like this, 10 and a half is true there. But it cannot represent how many uniforms I need. Okay, the only one that represents how much I need is H. What does J represent here?
And it should be the prices.
That's the prices. That's not my domain. That is my what?
Your rank.
Your
The
range.
range. Okay? You have to know what X and Y represent. I could have easily typed that into Desmos and pulled up the table like Mr. Reyes told me. But unless I knew what range and domain was, I might have picked H, I might have picked J. Right? You got to know it, guys. You got to know it. Okay, we're going to drop down to 8. On 8, which graph best represents negative 5y equals negative 6x plus 15? Okay, we're going to clear my Desmos graph, and I'm going to type this straight in. Negative 5y equals negative 6x plus 15. Oh, I forgot my y, sorry. All right, so I get a graph, right? Okay, anytime you need to refresh your graph or rezoom it, just hit the home button and it goes back to the default zoom. Okay, so I need a graph that looks like this, right? I want the one that is the same. First, what type of slope do I have on my Desmos function? Positive or negative?
Negative.
Careful.
Positive.
Let's take a look. Why is it positive? You're right.
Because it crosses.
Remember, pick 2 points on my graph. Doesn't matter, any 2. And we read it left to right like a book, right? If I'm at Six Flags, if I go from here to here, is that going up or down the roller coaster?
I'm going up the
It's
road.
going up. Left to right, just like a book. Okay, this is a positive slope. It is increasing. Okay, so I need the graph that has a positive slope. So which 2 can I cross out? Which 2 are negative?
A.
A, very good. Once again, pick 2 points. I read left to right like a book. That's going down. That's a negative slope. Cannot be negative. I need positive.
And B.
B, very good. B is also a negative slope. I need a positive slope.
It's C.
So now it's between C and D. Check it out. We can use the attributes of our linear function, which is this t, to help us determine which one it is. There's no guessing here. No guessing games, right? Let's take a look at the y-intercept. On C, my y-intercept is below my origin. On D, my y-intercept is above my origin. We need the one, let's look at Desmos. We need the one that's what? Below or above?
Below.
What's my answer here, guys?
C.
There we go. These are STAR questions from 2 years ago, guys. Your common assessment looks very similar to this on Friday. Okay? Any questions?
Nope.
Okay, let's look at the next one. We're going to take a look at question number 13. Okay, InSolve. Raise your hand if you know InSolve. Okay, some of y'all might have depended on that last year, right? For your STAR test, solving equations instantly with TI Inspires.
Yeah.
You will not have TI Inspires this year. Okay, but Desmos has a similar function. Take a look. On 13, what value of x makes this equation 1.25 times 4x minus 10 equals 7.5 true? I'm going to my Desmos graph. I'm going to type it exactly how I see it. 1.25, I see a parenthesis. I see 4x minus 10. I see a close parenthesis equals 7.5. Check it out. I get a graph here, and my solution is my zero. What is the zero of a graph, guys? It's where the graph touches the what? X-axis. Very good. What's my answer here? 4. Okay. 4. Y'all see how we can use that?
Mom gave me the wrong answer.
Yeah, double check your equation. Make sure. You got it? Okay. All right, guys. That's the in-solve method on Desmos. It works the same way. 17. Now, this one has a lot of terms in it, right? There's some derivative property on both sides. Guys, guess what? It works the same way. On this one, just make sure you type it exactly how you see it. 8x minus 3. I see a parenthesis. 2x minus 4, close parenthesis, equals 3. Open parenthesis, x minus 6, close parenthesis. It's a lot to type in, but guess what? Desmos does a hard work for you. If I cannot see it, guys, why do you think I can't see it?
You gotta zoom out.
I gotta zoom out, okay? Let's try to find it. Oh, I see it. Where's it at?
30.
30.
There you go.
80.
There you go. But once again, you have to know what to look for, guys. You have to know the attributes of the linear function, or you're not going to know where to look. You could type it in on you could type it in on Desmos, and you could just stare at that graph all day. Unless you knew that the solution to a linear equation is your zero. Okay, you got to know that. Okay, let's look at 19. Which table shows y is a function of x? Believe it or not, guys, this is that 6th grade TEK you learned about, function rule. What is function rule again? They follow one rule and one rule only.
No repetition.
Repetition. What do you mean repetition? What about it? What cannot repeat? X. Your x cannot repeat. Okay? This is how Algebra 1 asks that type of question. It's the same exact question from 6th grade. Only now, Algebra 1 uses different words. Which table shows y as a function of x? That just means which one is a function. That means x cannot repeat. On F, we got all these negative 13s repeating. Is that a function?
No.
No. On H, I got 1, 3, 7, 12. Is that a function?
Maybe.
Maybe. Let's keep looking. On G, negative 6, negative 1, negative 1, 10.
No.
No, it repeats. What about J? Negative 9, negative 2, 0, 0.
No.
No, it repeats. Guys, did I call out any Y's at all?
No.
Okay, cross them out at the beginning, guys, so you don't get confused. Some of y'all might have seen Y, all these 4s on H, but guess what? That's still a function because none of the X's repeated. Okay, the Y's can repeat all they want, but the X's cannot. All right, any questions there?
No.
Okay, feel free to stop me. Okay, 23, guys. Okay, just being completely honest. These will not be on the START test. However, they will be on your common assessments. Okay, so we got to take a look at it. When you come back to me in Algebra 2, we're going to take a look all about polynomials, how to add, subtract, divide, how to multiply, right? This year, you're not expected to know that for START test, but it is on the common assessment. So we have to figure out a way to do these. Guess what? Desmos will get them done for you. Okay? So on Desmos, I'm going back to my equation. I'm going to type in exactly what it shows me. Okay? It's very important, guys, that you type it exactly how you see it. Exactly how you see it. So if I see parentheses, I need to put parentheses. Okay, so I'm coming over here to Desmos. I have a parenthesis, 100x. Yep, minus 12. On 23, yep. Divided by. The divided by button is right by the shift. It's where the question mark is. Divided by, it's also known as a backslash. Negative Oh, that's not negative. Negative, in parentheses, negative 3 plus 25x. Close parenthesis. Okay? Now, this time, polynomials, division of polynomials. We're not looking at the x-axis. Now we're looking at
The Y.
the y. Where's it cross y at?
4.
4. So this answer is 4. Okay? Y'all see how we did that? Now, let's take a look at what happens when I don't write it exactly how it is. If I don't use parentheses, check this out. 100x minus 12 divided by negative 3 plus 25x. Right? If you type that straight in, guys, guess what? That's a rational function that's shifted 100 units. Right? You don't know rational functions yet. You won't know rational functions until second semester of Algebra 2. Use your parentheses, okay? It does make a huge difference. Are there any questions on these? All right.